Welcome back to Wildcat Academy. Today we're going to be factoring binomials and trinomials which only have a GCF. So a GCF is a monomial, either coefficient or variable or combination variable and coefficient that you can divide out of a binomial, trinomial, or other size polynomial. So looking at example 1 here, we're going to inspect this binomial. It's a linear binomial, and we can see that both terms, 4x and 4, are divisible by 4. So we're going to divide out the 4. Whenever we do that, we're just going to put that 4 out front, and then we're going to mentally think about dividing both terms by 4. And we can see that that 4 will cancel in the first term, and we'll be left with x, and then 4 over 4 simplifies down to 1. Now, factoring with the GCF, it's easiest, I believe, to think about this as division. All factoring is technically division, but with GCFs, I think in particular it's easier for us to think about that term by term, and we always do a quick inspection at the end of that step or this problem to make sure that we have done it correctly. So we take 4 and we redistribute that back into the binomial. 4 times x is 4x. 4 times 1 is 4. All right, so looking at example 2, this problem has a variable GCF. So we can recognize that because we have the same variable in both terms. So anytime you have the same variable in all the terms of the polynomial, we know we have a variable GCF. And with a variable, you can identify what the variable GCF is by looking at the exponents. So we can say we have an exponent of 2 in the first term and an exponent of 1 in the second term. We can factor out or divide out the exponent or the variable and exponent with the lowest exponent. So here that would be degree 1. So now we'll just divide each term by x, and we'll have x minus 1. So, and again, we're going to quickly check that mentally in our head to make sure we've done this correctly. X times x is x squared. X times negative 1 is negative x. And a quick check with the variables as well. When you're multiplying that back together, you can see that 1 plus 1 is 2, and then 1 plus no x's is 1. So that will help you determine if you've handled the variables correctly in each problem. All right, so in our next example, we have a combination here of variable and coefficient. We have another binomial. So we're going to look at the coefficients first, and we're just going to find the greatest common factor of these. 5 is a prime number, so it is only divisible by 1 and 5. So we're not going to worry about 1 because we're not going to factor out a 1. It's not going to help us simplify the problem. But 5 divides into both coefficients, so we're going to write that down as part of our GCF, and then we're going to inspect the variables. So we have y's in both terms, both degree 1, so we can divide out that y. So when we do that, 5 divides into 5 gives us a coefficient of 1, and then the y here divides into the y gives us 1. That leaves us with an x as the first term. And then 5 divides into negative 20 as minus 4, and y divides into y one time. And that's going to be it. So again, we're going to quick check. 5y times x gives me 5xy, and 5y times negative 4 is negative 20y. All right, so a little wrinkle here for example 4, so you can see that we have a leading coefficient that is negative. So as good practice with all polynomials and factoring, we do not want to leave the leading coefficient negative. We typically want to factor out that negative. So in later factoring, when we're factoring trinomials and difference of square, binomials, and difference of cubes, sum of cubes, even factoring by grouping, where we use factoring with the GCF as part of the process, we do not want to leave our leading coefficient as negative. So we know we're going to at least factor out that negative 1 there, but also 3 and 9 are both divisible by 3, so we can factor out a negative 3. And then as we inspect the variables, we have an x in both terms, so we can factor out the x, and then there's 4 y's in the first term and 3 in the second, so we can factor out a y cubed. And so that will leave us with a y in the first term, because negative 3 divided into negative 3 is a 1 coefficient. We pulled out the x, and we also pulled out 3 of the 4 y's, leaving us 1 right here. And then we're going to do the same division. Positive 9 divided by negative 3 gives me negative 3. And we pulled out that x, and all 3 of the y's came out front. We'll close that parenthesis up there. So again, we'll do a quick check. Just to make sure we've done this correctly, negative 3 times 1 is negative 3. Xy cubed times y is xy to the fourth. And then negative 3 times negative 3 is positive 9, and xy cubed times no variables accounts for the entire xy cubed, all the variables in the original problem. In example 5, we are dealing with a trinomial, so there are 3 terms, 3x squared plus 12x minus 21. And all 3 coefficients are divisible by 3. So we'll write that 3 out, and then we'll divide all the coefficients by 3. We do not have a variable GCF as part of our GCF in this problem because there are no variables in the last term, so we can rule that out. And I chose 3 here, a little trick that we always want to look at. Look for prime numbers when you're looking for GCFs, because that rules out possibilities that we might have. So because 1 and 3, the only possibilities to factor out a GCF of the first term is 3. So that will give us x squared as the first term, then 12 divided by 3 gives us 4x, and negative 21 divided by 3 is minus 7. And we can do that quick check again, multiplying back through. 3 times 1 is 3, 3 times 4 is 12, and 3 times negative 7 is negative 21. And the variable terms will be exactly the same. So the coefficients and exponents, or the base and exponent, should be the same in every term. All right, number 6 is a rather complicated GCF problem. You can see that we have 2 variables to deal with. We have a negative coefficient out front, so we know we're at least factor in a negative 1. And we're looking at the coefficients to determine what whole number value divides into all 3. Again, the trick here that I've shared with you already is that look for a prime number, and then that will help us determine if, how big of a GCF that we can possibly factor out. So we have 5 as the coefficient of the third term, so we're going to look here and see that 5 is the only possibility. And then we check the other terms, and we can see that 15 and 35 are both divisible by 5. So we're going to factor out a negative 5, and then look at the x terms. We can factor out the lowest exponent of x, which is x to the first power, and then look at the y variable terms. And we can factor out, it looks like a y squared. So we just divide here, negative 5 into 15 is positive 3. Subtract the exponents, because when we divide x cubed by x, the exponents subtract, be x squared, and then there will pull out both of the y's. And then we end up with negative 7. We're going to pull out one of the x's, so it becomes x squared becomes x to the first power. We'll pull out 2 of the y's, so this becomes a y. And then positive 5 divided by negative 5 is negative 1. Typically don't write that coefficient. We'll just let it represent by a negative there. And then we're pulling out the entire x right here. Okay, so we're pulling out that x to the first power. So there'll be no x's, and then we're pulling out 2 of the y's, so 4 minus 2 gives me y squared. All right, and that is it. If you haven't already checked out the channel, please subscribe. There are lots more videos on factoring, binomials, trinomials. Hit the subscribe button, like the video if you found it helpful, and look out for more great videos from Wildcat Academy.